Alright, so in this video we're continuing to work through this recursive formula question. I've just made a video for part 1, so if you haven't seen that already, I'll provide a link so you can take a look. In this video we'll focus on part 2, which says, observing the pattern established above, write an expression for fn in terms of f0 as an expanded sum of terms using plus dot 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 plus or dot 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 specifically to denote intermediate terms. So let's take a look. I've got here our working from part 1, so naturally part 2 is following on directly from part 1. It wants us to look for a pattern, and if I focus on f1, we've got 4 times f0 minus 1, okay? f2, we've got 4 squared times f0 minus 4 minus 1, okay? f3, we've got 4 cubed f0 minus 4 squared minus 4 minus 1. So just looking at those 3 terms, we kind of see a pattern where we have 4 to the power of whatever item we're up to times f0. So we have 4 to the power of 1 times f0, 4 squared f0 for f2, and then 4 cubed f0 for f3. And then we subtract reducing powers of 4. So when we're on f3, we get 4 cubed f0, and then minus 4 squared, minus 4 to the 1, minus 1, which you can think of as 4 to the power of 0. So actually what I might do is I'll turn over and we'll kind of flesh that out. So here for part 2, I think what we can say is from part 1, we see the pattern, and then we can write out fn is actually equal to 4 to the power of n times f0 minus 4 to the power of n minus 1, and then minus 4 to the power of n minus 2, and so on. We keep going until we get minus 4 to the power of 0, or just 1. Now we want to now write this in terms of an expanded sum of terms. So we've currently got minuses, but it's not hard to turn those into pluses. We can just factor out. So what we'll do is we'll say that's equal to 4 to the power of n times f0, and what I'll do is I'll factor out the minus. And maybe to make it really clear, I'll just write this in reverse order. So we'll have our 1, which is our new starting term, writing it in the reverse order. And then we'd have plus 4 to the power of 1. And I'm plussing here because I've already factored out all my minuses. And then we'd have plus 4 squared, and so on. And we'd keep going until we end up here. So we'd have plus 4 to the n minus 2. And then finally we'd have our plus 4 to the n minus 1. And that's pretty much it. I think for part 2, it's quite straightforward. It's only worth the 1 mark. But essentially the key to it is just looking at what we got from part 1 and noticing that pattern, and then being able to write it in this format where we notice that apart from this first term, the rest we can factor out the minus and end up with this sum of terms, all essentially powers of 4, noting that 1 is just 4 to the power of 0. So there you have it for part 2. Hopefully you've been able to follow along. So what I'll do is in the next video, we'll take a look at part 3. Alright, tick boom.